Good afternoon, guys. Very good luck with the quiz. Please don't get very tense. Do your best. I'm not going to be very strict. And just answer the questions exactly. Like, do not do what we were supposed to be doing. Just answer the questions as is. All right. So, first, I provided you with this video along with the Python quiz for students, the Jupyter notebook. And the very beginning of the notebook, we had the very necessary libraries to complete today's exercises. At the very end, these libraries are extra, and the code at the very end of this file is also an extra code that I will be using as part of the solution. So please do not worry about this code. You can just delete it altogether. In fact, I'm going to just delete it from your version here. I'm just going to delete it and delete the very few lines at the very end. So this is the file that you will be provided with. These all the libraries necessary for you. And over here, I'm not gonna tell you what data set I'm using as of yet, but I'm gonna read the data set for you. So I'm gonna have it embedded for you, and these are different variables in the data set. I'm gonna give you the description of the variables in the data set, so read it very carefully. And also I am going to split the data set into the X predictive variables, the independent variables. So the DF here is in fact a data frame that I created for you already that has all the X variables or the independent predictive variables, and the target has the Y or the target, the dependent variable. The dependent variable here is a mean value for prices of certain items. Okay, so the first question is to split the data set into 30 and 70, 30 testing and 70 learning. So I may be providing more lines than necessary to complete this exercise. Also over here, I'm providing way many more lines than required for completing this exercise as well, which is a cleaning exercise of the dependent variable in the learning and then in the testing. I am also hinting to you, please, to make sure that you have the X train, the Y train, X test and Y test all be converted into data frames. This is how you start, and also concatenate them, the Y's and the X's in the training and the Y's and the X's in the testing. Also, do not do any scaling, any independent variable scaling or even dependent variable scaling. So put this note very clearly to you. Don't do any scaling for the dependent or the independent variable. All right. Once you are done with this, please do the linearity assumption between the dependent variable and different numerical independent or predictive variables. Then test the multicollinearity. The multicollinearity, I would like you to test it visually and also with the multicollinearity, not visually, okay, visually, and with the statistical test. So you need to know what statistical test necessary. In fact, if you just read the libraries here, you can easily find out the important libraries needed to get the VIF. So I don't want it visually. Actually, we never do it visually, right? The multicollinearity is okay. We just you do it with the VIF. All right, you do it with the VIF, and then build the. I didn't give you the code to do it with the visually. So visually, you can actually plot the scatter plot of different independent variables together. But it's okay. Just use the VIF for time limitation. And you can also optimize your time by just using the code that we covered in class, the VIF code. All right, question 5 is building the linear regression model using the stats models library. Also, please make sure when you use the stats model library to build the model, before anything else, please use this line of code before building the model. So the first line of your code building the regression model should be this: the X train should include the constant. In class, we didn't include this line, and we ended up with a very high reading of the R squared and the adjusted R squared. And the problem was we didn't use the constant. I'm sorry, I just didn't figure this out until I was just solving this quiz on my own in a very clear environment here, and then I was like, oh wow, where's the constant? So it's very well known that the stats model, you need to add the constant into the fitting of the model. So please add this. Probably should add it here for you. You know what? Like that, and save. All right. Check the normality of the error term residual assumption visually. So this is just use the distribution the histogram or the distribution plot as we covered in class. And check the homoscedasticity assumption. So make sure that there's no heteroscedasticity. So this is with the Bruch-Pagan test and visually as well. All right, this is optional, but I'm just gonna get rid of it for you right now because I don't want to get you confused. So this is the quiz up to here, question 7. For the model evaluation, which is using the model with the testing data set, because so far we haven't had the time to do this, I'm going to cover this in another video solving this quiz. So I'm going to add the model evaluation into the solution of the quiz. So this is it for the quiz. Best of luck, and please make sure to meet the deadline submitting the quiz. Thank you so much.